Hi everybody, I'm going to do a bit of an introductory lesson to organic chemistry, which is C7 part of the specification for AQA Combined Science Trilogy. This is just going to cover the beginning of the topic and hopefully give you a bit of understanding. So the first thing is just have a look at these pictures and have a think, what do all of the pictures have in common? We've got a petrol pump, some plastic bottles, candles, Vaseline petroleum jelly, tarmac, pharmaceutical tablets, lipstick and a plastic football. Well, the answer is they're all made using crude oil. Crude oil is the raw material for every one of these objects. So what is crude oil? Crude oil is a fossil fuel. It is an extremely useful substance, however it's called crude for a reason. Crude oil is a thick, sticky mixture of molecules that are called hydrocarbons. Hydrocarbons are compounds that only contain hydrogen and carbon. This is a really important definition for AQA, so it is one that is needing to be learnt. Now, before we can do anything with the hydrocarbons, we have to separate them to make the oil useful. You can see from this picture that the crude oil is thick and sticky and dirty. It's not usable in its natural format. Now, almost all fuels are hydrocarbons, including petrol and diesel. So along with the products we saw earlier in the video, it is extremely important that we're able to separate these. Now, before we can learn about separating crude oil, we need to know a bit more about the hydrocarbons it contains. Now, if we think about science, we can break science down into three. Biology, the study of plants and living things. Chemistry, the study of chemical reactions and how chemicals interact with each other. And physics, which is the study of things like forces. Now, if we look at chemistry in more detail, chemistry also splits into three. Organic chemistry, inorganic chemistry, and physical chemistry. Just like biology, chemistry and physics, organic, inorganic and physical have very different types of study involved with them. You look at different things. Organic chemistry is what we're going to be looking at today. Now, if we look at these molecules, these are all examples of organic chemicals. Have a look at those chemicals and try and work out what they all have in common. If we look at those chemicals, all of the chemicals have got carbons in the middle. And that is what makes a chemical organic, if it has carbon as a backbone. Now, as well as the carbons, we have hydrogens as well. All of these chemicals have hydrogens. We find that there are some other elements that are in organic chemicals as well, most commonly oxygen and nitrogen, which we can see here, but you sometimes find chlorines, sulfurs and other elements as well. Organic chemistry follows rules for naming and drawing molecules, so that chemists around the world know they're talking about the same chemical. For the AQA exam, you have to be able to draw and name some of the organic chemicals that we find in crude oil. And there are some simple rules. If you see meth or meth, M-E-T-H, in an organic chemical's name, that means that there is one carbon on its own surrounded by other elements. If you see eth or eth, E-T-H, that means that there are two carbons next to each other, joined in a molecule, surrounded by other elements, just two carbons on their own. Prop or prop means that there are three carbons, and bute means that there are four. Meth, eth, prop, bute. Now you have to know those. Those are prefixes. They come at the start of a word. And you have to know how many carbons they correspond to. Now, after 4, from 5 carbons onwards, the part of the name that tells us the number of carbons is the same as for size of shapes, which is quite handy. Pent 5, hex 6, hept 7, oct 8, non 9 and dec 10. But how can we remember the prefixes for 1 to 4, which are the ones you need to learn? Try thinking of an acronym for the letters MEPB for meth, eth, prop and bute. You can pause the video and have a go. How about this one? Monkeys eat peanut butter. It's a bit silly, but it sometimes helps people remember. Meth, eth, prop, bute. Now, alkanes are the simplest organic family. They're hydrocarbons, so they contain only carbons and hydrogens. Remember, that's a definition that you need to know. Alkanes have carbon atoms joined by single bonds. Now, you're going to learn a bit more about bonds in a later topic, but for now we just need to know that that means there's one line joining them together. And all alkane names end in ane, A-N-E. That's how you can recognise if a chemical is an alkane. So we're going to have a look at an example of an alkane, and we're going to have a look at propane. Now, remembering the simple rules is going to allow us to draw the molecule. So the first thing we're going to look at is prop, which, as we saw before, means that there is 3 carbons joined together in the molecule. So we would draw the 3 carbons in a line, 1, 2, 3, prop. Propane tells us that this is an alkane, and alkanes have single bonds joining the carbons together. So we put a single line in between each carbon in our chain of 3. Now, at that point, we've used all parts of the name. Prop tells us there's 3 carbons, ane tells us that it's an alkane, and we have single bonds. And once we get to that point with organic naming, or nomenclature, which is its proper name, we then have a couple of other rules to remember. The first is that carbon bonds 4 times. Now, that's because it's in group 4 of the periodic table. Again, that's something you look at in a later topic, in structure and bonding. But what it means for us now is that all carbons in the molecule have to have 4 lines coming out of them. Now, if we look at the carbon in the middle, it's already got 2 lines either side. So what we do is we add 2 more, and that carbon now has 4 lines coming out of it, 4 bonds. Carbon on the left-hand side, the first one, has already got 1, and we add 3 more to give it 4 lines. And we do the same for the carbon on the right-hand side. And that's the first general rule for organic chemistry. Carbon bonds 4 times. The final rule is that we only have carbons and hydrogens because this is an alkane. So at the end of all of those lines we've just drawn, we're going to put hydrogen atoms to give us the alkane hydrocarbon that we need to draw. And that's the structure of propane. Pause the video here and have a go at drawing ethane. Okay, so to break this down, first of all we have eth. Eth means that we have 2 carbons. So we put 1, 2 on our paper. Next, we look at the fact that this is an alkane. So we only have C's and H's, and we have single bonds. So, first thing, single bond between the 2 carbons. And now I've done everything that I can with ethane. Eth, 2 carbons, alkane, single bonds. So the next thing we have to think is 4 bonds for each carbon. And because it's alkane, it is a hydrocarbon, so on the end of these bonds we put H's. And that's the structure of ethane. Again, pause the video, this time have a go at drawing butane. So as before, break the name down. Bute means 4 carbons, and ane means that we have single bonds and only carbons and hydrogens. So 1, 2, 3, 4 carbons for bute, single bonds between them because it's an alkane, 4 bonds for every carbon, and hydrogens on the end to give us butane. Don't forget to add the hydrogens, it's a very common mistake. People add their sticks for the bonds and then forget to put the H's on. But there's butane. So to finish off, a little bit of a quick quiz. Test yourself on the video by answering the following true or false questions. This is an organic molecule. True or false? This one is true because we only have carbons in the centre with hydrogen surrounding it. Carbon in the centre means we have a backbone of carbon, therefore it's organic. How about this one? This is an organic molecule. This time in the centre we have silicon, not carbon, so this one is false. This is a hydrocarbon. Remember that hydrocarbon means only carbons and H's. If we look at this molecule, it's true. How about this molecule? This is a hydrocarbon. This time we have an oxygen in the molecule, which is not a CRH, and therefore this is false. This is butane. As we said before, but means 4 carbons. And if we look at our molecule here, we've got 1, 2, 3 in a line. So this is not butane. What is it? This is propane. And finally, a bit of a challenge. This is an A-level chemical. I've got 3 possibilities of what this chemical could be and what its name might be. 1, is it 2-amino-4-methyl-pentanoic acid? Question 2, is it 2,7-dimethyl-3,5-octadiene-2,7-diol? Or 3, 2,4,6-trinitromethylbenzene? Now a hint is how many carbons do we have on the backbone? We have 1, 2, 3, 4, 5. And if we look at our 3 possible names, we can see that we have pent in this first one. So the answer is number 1. It is 2-amino-4-methyl-pentanoic acid. The others, we have 1 carbon here, but we have 8. So that's 8 carbons. Can't be that one. And the last one, benzene's a bit complicated. If you fancy a real challenge, go away and have a Google of those molecules.